Hey guys, here's just a couple last minute things before our test next week. We're going to go ahead and graph this problem right here, but there's a couple things we want to talk about. Asymptotes. We've had vertical asymptotes and horizontal asymptotes, so we're still going to do them, but we're also going to talk about slant asymptotes. So it's just one extra asymptote that you'll need to be aware of. End behavior is something that you've probably talked about before, so it's going to be a little bit of a review today. And then we'll talk about restrictions. It doesn't necessarily apply to this problem, but I can apply it to this problem anyway. It doesn't matter. Okay, so let's go ahead and talk about graphing this. Okay, first thing I notice right off the bat is the degree of the numerator is greater than the degree of the denominator. So that tells me one thing right off the bat, that we are not going to have a horizontal asymptote. Okay, so let's go step by step. The order that we normally take is finding the x-intercepts. Okay, so the x-intercepts, we find those by setting the numerator equal to 0. So x squared minus 4 equals 0. Okay, and subtract 4, x squared equals 4. And so x is going to equal plus or minus 2, right? If I take the square root of both sides. Okay, all right, so got that taken care of. All right, let's find the vertical asymptotes. Okay, the vertical asymptote we find by setting the denominator equal to 0. So x minus 1 equals 0. So x equals 1. Okay, we already discussed the horizontal asymptotes. We don't have any. That's because the degree of the numerator is greater than the degree of the denominator. And now finally, one thing we have to add, and it only happens in this case, okay? When the degree of the numerator is greater than the degree of the denominator, that's when you're going to get your slant asymptotes, okay? Unless I'm mistaken, but I'm positive it only happens in this case, okay? And how we do that for the slant asymptote, we're going to take the numerator, divide it by the denominator, okay? So you can do this, x squared minus 4, and divide it by x minus 1, okay? But in this case, our problem is actually a little simpler. If you notice, this is x minus 1. It's a binomial with a leading coefficient is 1. We don't have to divide this way. We can actually use, okay, we can actually use synthetic division, right? What's going to go here? Well, it's 1x squared. And then the next represents the number of x's we have, which is 0, okay? And then we have a negative 4. And then what's going to go right here? Well, if we're dividing by x minus 1, what goes right here? Just a positive 1, okay? All right, and then so I'll bring this 1 down, multiply, combine it, multiply, and then negative 4 plus 1 is negative 3, okay? Now keep in mind, this is 1x squared, so when I run it through the machine here, this drops down to power, so this is 1x, okay? And this is plus 1, and then this is a remainder of negative 3, okay? We don't really need to worry about the remainder when we're finding the slant asymptote, okay? So my slant asymptote is simply going to be f of x equals this guy right here, x plus 1. All right, there's my slant asymptote. All right, so now let's go ahead and mark this stuff up on my graph, okay? So here's my graph. All right, so my first thing to do is write down the x-intercepts. So I have x-intercepts of positive and negative 2. So here's an x-intercept here and an x-intercept here. Okay, I have those two x-intercepts. Then it says I have a vertical asymptote of x equals 1. So that's this guy right here. All right, got that guy. All right, then it says I don't have a horizontal asymptote, and then it says I have a slant asymptote of f of x equals x plus 1. Okay, let me show you again. Remember, y equals x plus 1, same thing. All right, the slope is 1 over 1, up 1 over 1, and the y-intercept is 1. Remember that, y equals mx plus b, slope x plus b y-intercept. Okay, so the y-intercept is 1. All right, so I'll go up 1. Here's my y-intercept right here. The slope is 1, right? The slope is 1, so up 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, just like this. And also down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. Okay, and so here is my slant asymptote. Okay, I'll go ahead and connect these dots here. This is going to be my slant asymptote. And I promise for the test it's not going to be any harder than this. I don't think. I hope not. Oh my gosh, wouldn't that be horrible? All right, so there we go. Now I have my two asymptotes, okay? I have my vertical asymptote and I have my slant asymptote, okay? And so now all we have to do is make a t-chart. Okay, we'll make a t-chart. X and Y. I know that since I have a vertical asymptote here, I'm going to try to get some points this side and points that side, okay? And I'm just going to go from -5 to +5, okay? So here we go. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, okay? And I'll go ahead and grab my calculator, okay? Turn it on. I'll go to this, and I have the equation y equals x squared minus 4, so don't forget parentheses, x squared minus 4, close the parentheses, divided by x minus 1, don't forget parentheses, so x minus 1, close parentheses, and let's hit the table, okay? So my table, I'm going to go from -5, okay? So -5 says -3.5, -4 is -2.4, -3 is -1.25, -2 is 0, -1 is 1.5, 0 is 4, let's scroll down here, 1 is error, okay, so undefined right there, 2 is 0, 3 is 2.5, 4 is 4, okay, and 5 is 5.25. All right, cool. So now let's go ahead and plot these points. Okay. See if you guys could see both of it there. Okay. All right, so -5 and -3.5. So 1, 2, 3, 4, 5, and down 1, 2, 3.5 is right here. Okay. -4 and -2.4. So 1, 2, 3, 4, and down 1, 2.4. That's right here. -3 and -1.25, 1, 2, 3, down 1.25 is right there, okay. Let's see, -2, 0, got it. -1 and 1.5, so -1 and 1.5, that's right here. Okay, 0 and 4, so 1, 2, 3, 4. All right, 1 is undefined, okay. And let's do the other side. 2, 0, got it, 2, 0. 3, 2.5, so 1, 2, 3, 2.5 is here. Okay, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then 5, 5.25, 5.25 is right here. Okay, so now I don't know if you guys can see it, but we definitely have a curve, right? If you connect the dots, right? If you just connect these dots, they curve a little bit, but look at this. Let's do the ends here. This guy's going to continue this way, but look, there's an asymptote, so it's going to hug this asymptote. All right, and then if you connect this guy here, that's going to hit that asymptote and hug that guy right there. So we got that, okay? Connect these dots here, okay? Connect these dots. And if you look, they're going to do the same thing. This guy's just going to hug this asymptote here. Okay, and then this guy's going to curve up and hug this asymptote. All right. All right, so there we have our graph. Okay, so what did you learn so far? Let's go back here. Slant asymptotes. That's this guy. That's the new guy that you're going to use, okay? And it only happens when you have this type, okay? All right, now let's talk about end behavior. All right, the end behavior is talking about what's happening to the right, what's happening to the left. It's not necessarily talking about the middle. Don't worry about that middle stuff, okay? We're talking about what's happening on the right side, what's happening on the left side, okay? So, as x, right, goes to the right, that's positive infinity, right? As x, the values of x are getting bigger and bigger and bigger, okay? Then f of x, okay, remember that's y, that's the same thing as y. So as we go to the right, as this line goes to the right, it's going to the right, but it's also going up, isn't it? Okay, so as this is going to the right, it's also going up. So we know that y, or f of x, is also going up, so that's positive infinity, okay? All right, and let's talk about to the left, okay? What's happening? Look at this graph. It's going to the left, but it's also going down. So as x goes to the left, that's negative infinity. F of x, or the y direction, that's going down. So in this direction, that's also negative infinity, right? Okay, so there's your end behavior. Again, that should just be review. This part right here in the middle, don't worry about that. Okay, you don't need to worry about that. You're only concerned with the end behavior over here on the ends. Okay, the left side and the right side. Okay. Finally, there are restrictions, okay? So we did slant asymptotes, we did end behavior, and now let's talk about restrictions. If you, on your test, get a problem that says something about restrictions, okay, all you have to do is look at the denominator, okay? The denominator says x minus 1. Well, remember, you cannot have a denominator that is 0, okay? So what value of x would make this denominator 0? If x is 1, then 1 minus 1 is 0. So your restriction here is x cannot equal 1. Okay, that's your restriction. X cannot equal 1, because if you put a 1 here, 1 minus 1 is 0, and then that's undefined, okay? All right, so let me just show you one more thing really quick. If I have something like this, let's see, x squared minus 4 over x minus 1, I don't know, okay, divided by, right, x minus 5 over x minus 3. Okay, let's talk about the restrictions, okay? Well, let's talk about these restrictions. We know that x minus 1, this guy can't be 0, so solve it for 0, right? So we know that x cannot equal 1 if I solve that for 0, right? I'm set it equal to 0, okay? This guy here, x minus 3, this can't be 0, so what value of x can we not have? What's our restriction? Well, x cannot equal 3. But here's one more thing that you have to keep in mind. If you have x squared minus 4 over x minus 1 divided by this, well, in the process of simplifying this, you get x squared minus 4 over x minus 1 times, now you flip this so you get x minus 3 over x minus 5, and now look, that can't be 0. So we know that x minus 5 can't be 0, so x cannot equal 5. So now we have this restriction, and this restriction, okay? So those are the restrictions. All right, guys. Good luck. Let me know if you need anything. Talk to you soon.